Okay, last problem here on these notes for 4.5 is this application problem. It's pretty like in depth, or it looks pretty intense, I should say, but it's just a plot, and they're going to ask us, give us a trig function that will fit this curve. Okay, so there's a couple of different ways we can start this. I'm going to make the argument here that this graph is getting cut in half here, like right around in this area. That x-axis doesn't act like a halfway point, so I'm going to say that the graph is kind of getting cut up here somewhere. Like I said, because it's not symmetrical about that x-axis, which is what we would like it to be. Okay, so all that being said, like I said, I'm going to do this little imaginary here. So if we look at the graph does not start on this line that we think that it's shifted up to. It's starting below it. So I'm going to say this looks like cosine. Okay. It does look like negative cosine, but for this last example, we're going to throw it all together. We're going to do a horizontal shift. I'm going to show you what it looks like so you guys kind of see the whole thing. This problem is in your book as well, so I'm just trying to mirror kind of what they do. So it looks like cosine. And so my equation is going to be of the form y equals a cosine b x minus h plus k. And we're actually going to get a, b, h, and k. We're going to get all of this stuff. All right, to find the amplitude, we're always going to take 1/2 the absolute value of the highest point. And it's tempting to look at the graph here for the highest point, but let's look at the table instead. The graph's highest point occurs at 38,000. So 1/2 of 38,000 minus the low point, which is 900. Okay, 38,000 minus 900, that's going to give us 37,100, and you take half of that, you'll get 18,550. So that's my amplitude. It's pretty tall, but look at the numbers we're dealing with, that kind of makes sense. All right, another way we can find the horizontal shift, and this is going to be helpful in, vertical shift. This is going to be helpful in a problem like this, is we can do 1/2 the max and the min added together. In the previous example, we could just visualize it a little bit and we would be all right. But in a problem like this where you're getting data points and you're trying to make it happen, it's a little easier to do the math. So 1/2 the average of those two values, 1/2 of 38,900, we would get 19,450. That's our K. All right. Now, we're going to get a little creative with the period. And I mentioned to you in a previous problem that the horizontal distance between the max and the min is half the period. Or I think I said the horizontal distance between like two mins or two maxes is going to be the full period, but we don't kind of have that luxury here. So I'm going to say the horizontal distance between a max and a min is half the period. So if I want a full period, I'm going to double that horizontal distance between the max and the min. All right, now horizontal distance is going to be months. So we know that the max occurs at 38,000, May, 5 for the month of May. And we know that the min occurs in November, 11 for November. That min is 900. So we're going to do 2 times 11 minus 5. 2 times 11 minus 5 is 6, times 2 is 12. 12 is my period, it is not my b. So I'm going to say 12 is equal to 2 pi over b. We'll get b is equal to 2 pi over 12, or b is equal to pi over 6. Oh, okay. So there's A, there's K, there's B, H is left. Last thing that we're going to do. Cosine starts at its max or its min. That's kind of the rule. So cosine starts doing the maximum at 5, when x is equal to 5. So as opposed to like trying to be like fancy and saying, oh, this is going to be negative, we're going to do something like that, we're going to say, listen, it's going to start here at the maximum, because that's cosine starts up high. It's going to start at the maximum, and that's where my shift is going to be. So 5 is equal to x is where the maximum, that's where the h is going to be. So to throw this all together, y is equal to, we said A was 18,550 cosine x minus pi over, oops, I lied to you. Ooh, sorry. 18,550 cosine, and this should be, here, I'm just going to rewrite this. Try this again. Y equals 18,550 cosine, let's put the b in there, pi over 6, x minus 5, x minus h, so it looks like a positive 5, it looks like a negative 5 in the problem, and then plus your k is 19,450. There are multiple correct answers for this problem. This is the way your book does it. This is probably the way I would do it, but this is definitely the most challenging problem in this section. If you feel confident with the ones that we did before and you needed a challenge, this would be kind of your challenge question.